So basement perfectly stocked with, 3 weeks of bottled water, canned beans, AA batteries.
All right.
You'd think that's the dream, right?
Hmm.
But it might actually be the most fragile room in your house.
Yeah, absolutely.
And today, we're kind of tearing down that whole myth of the doomsday bunker in this deep dive.
It really is a completely different way to look at preparedness because, we're so conditioned to view a well-stocked home as the ultimate safety net.
Right.
But the research we're exploring today, it shows that even an overflowing pantry, it shatters instantly if the home's normal operating pathways fail.
Wow.
And, if it has no capacity to switch into a different state.
Which is, that feels like a massive contradiction to everything we've ever been taught.
Oh, yeah.
Like the 72-hour kit, right? Or the 2-week emergency pantry.
The gold standard.
Exactly. These are the gold standards of household readiness. So I can say the question is, if hoarding supplies doesn't actually make a home resilient, what does?
Well, it really comes down to a fundamental distinction between enduring a crisis and actually recovering from one.
Okay.
Because stockpiles of finite resources, so, water, fuel, cash, they simply extend the amount of time a household can endure a disruption.
So they just buy you time.
Exactly. They press pause. But alternative pathways, they allow life to continue in a different form.
Got it.
So enduring a pause in your life and actually switching the way you live, those are two completely different mechanisms of survival.
Right, because if a home is just sitting there paused, just waiting for the world to fix itself, it's actually highly vulnerable.
Extremely.
So to really grasp how we're supposed to be, I guess, switching these pathways, we first need to completely rethink what a house actually is.
We do, yeah.
Because most of us just see a box, right?
Right.
A box with a roof, some walls, maybe a nice yard.
A fortress.
Yeah, fortress. We think of it as this independent structure.
But that independent structure is, well, it's an illusion. It's an illusion created by modern convenience.
Yeah.
Well, if you look at the architecture of daily life, a modern home is entirely dependent on this massive invisible web of external systems.
Oh, sure.
We're talking about the electrical grid, municipal water pressure, the telecommunication fiber,
Right.
and even, complex logistics and supply chains, digital payment networks, local sanitation services,
Absolutely.
everything. A home is really just a highly dependent node plugged into a sprawling network.
So let's pull on one of those threads to see how this actually works in practice.
Yeah.
The most obvious one is a power outage.
Classic example.
Yeah, because normally we just think, okay, the lights are out, I'll go grab a flashlight.
Right, but look at the physical mechanics of a modern home during an outage. The disruption cascades almost immediately.
Oh, totally.
So your internet router dies, right? That severs your local Wi-Fi.
Yep.
And the cell towers in your neighborhood, they might have brief battery backups.
Those don't last long.
No, when those deplete, or honestly, when the network just gets overloaded by everyone suddenly using cellular data all at once.
I had to check the news.
Exactly.
Yeah.
Your communication to the outside world is severed. And it's not just digital either. Think about your heating.
Right.
People often assume that if they have a gas furnace, they'll be warm during a winter blackout.
Well, yeah, because they're burning gas, right, not electricity.
Right, but modern gas furnaces, they require electricity to run the blower motor. The motor that actually pushes the air through the vents.
I didn't even think about that.
Yeah, and they require electricity for the digital control board, the electronic ignition.
Man.
Even your smart thermostat requires a trickle of power and often an active Wi-Fi connection to a cloud server just to tell the furnace to turn on.
That is wild.
So without the electrical grid, that mechanical gas infrastructure is completely immobilized.
So you're just freezing.
Pretty much. And your food preservation clock starts ticking as the fridge warms up. And depending on your municipal water system, water pressure might even drop if local pumping stations lose power.
So the disruption basically strips away the illusion.
It does.
We suddenly realize how many, completely disparate parts of everyday life were just quietly piggybacking on that one single cord connected to the power grid.
Precisely.
It wasn't just illumination. It was our climate control, our food supply, our communication, our hygiene, all of it.
Yeah, and the structural takeaway here is that a home is not just a building. It's an interface.
An interface. I like that.
Yeah, it is the specific physical location where all these external high-level infrastructures are essentially translated into everyday human life.
Okay, so if a home is just an interface for these, external rivers of resources, then throwing a stockpile of finite supplies at a broken connection doesn't actually fix the system.
No, not at all.
It just delays the inevitable.
Exactly.
So how are we supposed to recover then?
By establishing what systems engineers call pathways.
Pathways, okay.
Yeah, let's trace how this works using communications as an example.
Sure.
So on a normal Tuesday, you are operating on what we call your primary pathway. Let's say that's a fixed fiber optic broadband line running directly into your house.
Right, so you're streaming 4K video, you're running smart home devices, taking video calls.
Yeah.
High bandwidth, zero friction. Life is good.
Life is great. Then a construction crew down the street accidentally severs the fiber line.
Oops.
Your primary pathway is gone.
Right.
The resilient home immediately shifts to a fallback pathway.
Okay, what does that look like?
In this case, you toggle your devices to run off your smartphone's mobile data network.
Just use your hotspot.
Exactly.
But there's a physical limitation there, isn't there? I mean, if the fiber line is cut for the whole neighborhood, suddenly hundreds of households are doing exactly the same thing.
Oh, yes.
They're all pinging that same local cell tower.
And radio frequencies can only handle so much data throughput at once, so the cell tower becomes massively congested.
Yeah, I've been in stadiums where that happens. You have bars, but nothing loads.
Exactly like that. You can no longer stream video or hold a Zoom call.
So what do you do?
Well, this forces you into a highly misunderstood state of resilience. It's called degraded mode.
Degraded mode.
Yeah, degraded mode. When everything cannot be maintained, essential functions are preserved while less important functions are temporarily reduced.
Okay, so you stop trying to push high bandwidth data.
Right. You limit your use to asynchronous, low bandwidth communications. You send text messages to check on family.
It's just the basics.
You pull down basic text-based news updates. You are no longer operating at 100% functionality, but you are still operating.
Got it. So you preserve the essential function, which is, staying informed and in touch, while shedding the non-essential functions like streaming movies in 4K.
Precisely. And you remain in that degraded mode until the utility company splices the fiber optic cable back together.
Right.
At that point, you hit the fourth phase, which is reconnect.
Reconnect.
You switch back to your primary pathway and you return to normal operation.
Okay, primary, fallback, degraded mode, reconnect.
That's the cycle.
That sequence makes perfect sense for data. Let's apply that to electricity.
Okay.
So primary is the grid.
Yep.
It fails. My fallback might be, I don't know, a portable power station, maybe a big lithium-ion battery bank hooked up to a solar panel,
Sure.
or even an inverter connected to my car's alternator.
Those are good fallbacks. But notice the shift in capacity.
What do you mean?
Well, your primary pathway, the grid, provided effectively unlimited amperage.
Oh, true.
You could run an electric dryer, a dishwasher, and a central air conditioner simultaneously.
Yeah, without even thinking about it.
Right, but your fallback pathway, whether it's the battery or the car inverter, it has a hard physical limit on both output and duration.
Which means I have to drop into degraded mode.
Exactly.
I can't just pretend the outage isn't happening. I use the battery strictly to keep the refrigerator compressor running, a few times a day. I use it to charge our phones for communication and maybe to power a couple of LED lights at night.
So you preserve the food, you preserve communication, and you preserve safety. And everything else stops.
Hang on, I'm struggling with this degraded mode idea a little bit.
Okay.
Because the whole concept of resilience, especially in popular culture, it's about bouncing back. It's about invulnerability.
Right, the bunker mentality.
Yeah. If I've spent thousands of dollars to be resilient, shouldn't I be able to just, flip a giant transfer switch and keep my entire life running at 100%?
You think so?
I mean, why should I accept degraded mode? It sounds a little like giving up.
It does, but honestly, that is the most common trap in preparedness planning. Demanding 100% functionality actually makes the system deeply fragile.
Really?
Yes. Let's look at the physics and the economics of trying to maintain 100% of a modern home's electrical load off-grid.
Oh.
To do that, you can't just use a small battery or a portable inverter. You need an industrial-grade diesel standby generator.
Oh, wow. Yeah, a massive one.
And that requires a huge initial capital investment.
Thousands and thousands of dollars.
Tens of thousands. It requires continuous specialized maintenance. And critically, it requires storing hundreds of gallons of stabilized fuel.
Which is a nightmare.
It creates a major fire hazard, and the fuel degrades over time.
So you basically build this massive, complex fortress of infrastructure
Yeah.
just to avoid the inconvenience of a blackout.
Yes. And if any single component of that complex fortress fails, if the starter battery dies, if the fuel lines gunk up,
Or part breaks.
if a mechanical relay gets stuck, you drop instantly from 100% functionality down to 0.
Wow.
The rigid tree snaps in the wind.
Oh, I see.
The willow survives because it bends. Degraded mode is essentially the engineering equivalent of the willow tree.
It makes me think of a marathon runner.
How so?
Let's say you're running a race, and at mile 15, you realize you missed a water station and you're becoming dangerously dehydrated. The rigid 100% or nothing approach would be to stubbornly maintain your target pace until your muscles cramp and you literally pass out on the pavement.
Right. You crash completely.
Exactly. But the degraded mode approach is realizing your physical conditions have changed and your input of resources has dropped.
Right.
So you slow down to a brisk walk. I mean, you aren't going to hit your personal record.
No.
But you preserve your essential function, which is staying conscious, moving forward, and eventually crossing the finish line.
That's a brilliant analogy. You intentionally sacrifice performance to ensure continuity.
Yeah.
And the sources we're looking at apply this logic to every aspect of the household.
Oh, not just power.
Right. Take heating and cooling. Instead of running a 3-ton central air conditioner to keep a 2,500 square foot house at a crisp 68 degrees.
Which takes an insane amount of energy.
Exactly. Instead of that, you consolidate the family into one central room.
Oh, okay.
You hang blankets over the doorways. You run a small, low amperage window unit or a space heater just for that room.
So you're treating just the space you're in.
Yes. By drastically shrinking the cubic volume of air you need to condition, you drop your energy requirements by 80 or 90%.
That's incredible.
Yeah.
And it goes beyond utilities too, doesn't it?
It does.
Because the sources, they talk about logistics and supply chains.
Yeah.
If there's a major disruption to local commerce, degraded mode means shifting from, varied impulse-based shopping habits.
Running out to grab one ingredient.
Right. You shift from that to purchasing only absolute caloric and hygienic essentials.
Yes.
And it might even mean changing your physical mobility, right?
Oh, absolutely.
Like instead of driving 20 miles across the metro area for various errands, you figure out how to operate entirely within a 2-mile walking radius of your front door to preserve fuel.
Exactly. And when you visualize this state change, it shouldn't look like a cliff where you fall from 100% straight into the dark ages.
Right. It's not binary.
It's a dial.
A dial.
You start at 100% functionality. A disruption hits, and you dial the household's energy and consumption down to 60%.
Okay.
The situation drags on, resources get tighter, you dial it down to 40%.
Wow. Okay.
The family is still functioning, just slower and smaller.
Yeah.
Then, as the external systems begin to repair themselves, you dial back up to 80%.
And finally, the grid is stable.
And you reconnect at 100%.
So resilience isn't about maintaining a perfect 100%.
Not at all.
It's the ability to fluidly move between these different states of operation without the whole system crashing.
That's the core of it, yes.
That takes a lot of the pressure off, actually.
It really does.
But, it also raises a massive red flag for me.
Uh-oh. Why is that?
Well, if switching pathways and shifting gears is so fundamentally important to survival, why does it feel like our modern homes are actively being designed to prevent this?
You're touching on the convenience paradox.
The convenience paradox. Okay, explain that.
We live in an era of unprecedented integration. Automation, cloud services, cashless payment networks, the entire smart home ecosystem.
Right.
We are constantly optimizing for the removal of everyday friction.
And, it feels like magic on a normal day.
It is magic.
I can use an app on my phone to unlock my front door, turn on the porch lights, adjust the thermostat, and reorder groceries all from my couch. It's incredibly efficient.
It is highly rational during peacetime, but mechanically, what are you doing to your household's architecture?
What do you mean?
Well, historically, opening a door required a mechanical metal key.
What?
Changing the temperature required physically turning a bimetallic strip thermostat on the wall.
Right.
Making a phone call required a copper wire going to a telecom pole. These were disparate, physically separated pathways.
So if the power went out, my front door still worked because it was just a deadbolt.
Exactly. Now look at the smart home. You have taken all of those historically separate, redundant pathways.
Oh, I see where this is going.
And you've routed them through a single Wi-Fi router,
Yep.
which connects to a single internet service provider, which authenticates via a single cloud server located in a data center hundreds of miles away.
Wow.
You have merged everything into a single point of failure.
So if there's a localized internet outage, or even if Amazon Web Services goes down for 3 hours,
Yep.
I don't just lose the ability to stream a movie. I lose the physical ability to unlock my front door or turn on my heat.
Exactly.
We've traded all our fallback pathways for efficiency.
We really have.
We paved over all the little dirt roads and county highways to build one giant frictionless superhighway.
That's a great way to put it.
But if there's a 10-car pileup on the superhighway, the entire region is paralyzed because there are no alternative routes left.
And the illusion runs even deeper than that.
Seriously, how?
Well, let's say you recognize this danger. You decide to build a fallback pathway. The trap here is confusing route availability with route accessibility.
Route availability versus route accessibility.
Yes. Just because a pathway exists on paper doesn't mean you can actually travel down it when the pressure is on.
Break down the mechanics of that difference for me.
Let's go back to the generator example.
Okay.
You recognize the grid is a single point of failure. So you go to the hardware store and buy a portable gas generator.
Done. I feel safer already.
You put it in your garage. That is route availability.
Okay.
The fallback pathway physically exists on your property. But a year goes by, a severe winter storm hits, knocking out the grid. You roll the generator out, pull the cord, and the engine seizes up.
Oh, because you left standard E10 gasoline sitting in the tank for 12 months.
Exactly. The chemistry of it gets you.
It does, yeah.
The ethanol in modern gasoline is hygroscopic. It absorbs moisture directly from the air.
Oh, I didn't know that.
Yeah. So over a few months, the fuel degrades, water separates out, and a thick varnish clogs the tiny jets in the carburetor.
So it's useless.
Completely. And even if the engine did run, perhaps you realize you never actually hired an electrician to install a manual transfer switch.
Oh, so you can't even plug it into the house.
Right. You have no safe way to inject that power into your home's circuit breaker without, electrocuting a line worker on the street.
Man. So the route is available, but it is completely inaccessible.
Precisely.
It's just a theoretical pathway.
Yeah.
It's like looking at a map and seeing a bridge over a river. But when you drive there during an evacuation, you find the bridge is locked behind a steel gate and you don't have the passcode.
That's exactly it. The equipment is present, but the practical knowledge and the maintenance required to activate it are missing.
That is sobering.
And we see this in digital infrastructure, too.
How so?
Think about mobile telecom networks. Say you have a backup 5G hotspot for when your home internet drops.
Okay, a lot of people have those.
Route availability is having the device charged on your desk.
But route accessibility is dealing with the telecom provider's back-end infrastructure.
You got it. You might have a contract condition that caps your high-speed data at 10 gigabytes.
Oh, right.
Once you hit that cap during an emergency, the network's management software automatically throttles your connection down to 2G speeds.
Which is basically dial-up.
Yeah. Suddenly, you can't load complex emergency management maps. You can't access critical web portals.
The pathway exists on the cellular network.
Right. The radio waves are physically reaching your house.
But administratively, you are locked out of the flow of data.
Exactly.
Wow. So just owning the gear, the generator, the hotspot, the water filter, it doesn't mean you have a pathway.
No.
You have to actively maintain the ability to travel down it.
It's an active process.
And this completely shifts how I'm visualizing the house now. It's not a static box receiving deliveries. It's an active, dynamic machine.
It is. The most accurate way to view a resilient home is as a routing node.
A routing node, like an internet router.
Think of the actual internet router blinking on your desk right now.
Okay.
It takes raw, chaotic data packets from the global internet and processes them into a smooth, usable Wi-Fi signal for your specific devices.
It directs the traffic, prioritizing what needs bandwidth and what doesn't.
Yes. Your entire home operates on that exact same principle for the physical systems of civilization.
I never thought of it that way.
Yeah, it takes the raw, massive inputs of the outside world. So the high-voltage power surging through regional transmission lines, the highly pressurized water coursing through municipal mains.
The complex global supply chains.
All of it, and it steps them down. It converts those raw fluctuations into a stable, livable state for the human beings inside.
It literally translates the chaos of municipal infrastructure into a warm living room, a flush toilet, and a cooked meal.
Beautifully said. And when a disruption hits, the home has to actively make routing choices.
Because the inputs have changed.
Exactly. The node must decide, what do we shut down? What essential circuits do we keep running?
Where do we switch our connection?
How deeply into degraded mode must we drop to match the new reality of our resources?
But And tell me if I'm wrong here. A router can't route data if there's no broader network to connect to, right? That is correct.
A home can't be resilient in a total vacuum.
That is the ultimate boundary line of household resilience. Your home's internal switching capacity is completely useless if the external world doesn't provide an alternative connection point.
Okay, so if my home's primary water main breaks, my fallback pathway might be to take a wagon and some 5-gallon jugs to a local municipal water distribution point.
Right, a solid fallback plan.
But if the city planners haven't maintained those emergency distribution sites,
Then what?
my internal plan hits a brick wall. I mean, I have the buckets, I have the physical fitness, I have the routing logic.
But there is no water to connect to.
Right. So if the primary power grid fails, my fallback might be to move my family to a community shelter or a public library to get warm and charge our devices.
Yep.
But if the local public services haven't maintained independent backup power for those facilities,
Your fallback fails.
my fallback fails.
Because your home's resilience is intrinsically tied to the structural resilience of your city, which means the stakes are so much bigger than just what's sitting on the shelves in your basement.
Much bigger.
You can be the most meticulously prepared individual in your neighborhood. You can have your primary path, your fallback path, and your degraded mode perfectly engineered.
Flawless on paper.
But if your municipality, your county, or your regional grid has failed to build alternative pathways into its own civic design, your home remains fundamentally vulnerable.
It does.
The boundary of your home's safety doesn't stop at your front door. It extends straight into the city council chambers and the utility planning offices.
It's an ecosystem, really. The node requires the network, and the network is composed of nodes.
Wow. Let's bring all this together, because this is a profound shift in how we approach the unknown.
It changes everything.
We started by looking at the classic image of the doomsday bunker, right?
The basement full of beans.
Yeah. The idea that a home's strength is a rigid, fixed state, measured purely by the tonnage of supplies it hoards behind a locked door.
And we've seen the mechanical reality that hoarding is just pausing. It's holding your breath underwater.
Yeah.
True resilience is finding a snorkel. It's the ability to change the way you breathe.
We've mapped out how a home is actually a complex bundle of external connections. We've seen that switching pathways requires a completely different mindset than stockpiling.
Absolutely.
We've unpacked the uncomfortable but vital physics of degraded mode. Understanding that dialing your life down to 60% or 40% isn't a failure, it's a successful strategy for maintaining continuity.
It's how you survive.
We've exposed how the convenience of smart technology is quietly erasing our alternative routes. And we've realized our homes are just routing nodes that absolutely depend on the wider civic network.
All of which points directly to the central observation of the research, which synthesizes this perfectly.
And what's that?
A resilient home is not simply a home that never fails. It is a home that can change states, preserve essential functions, and reconnect to the wider systems of civilization.
A home that can change states, preserve essential functions, and reconnect to the wider systems of civilization.
That's the core of it.
So for everyone listening, here is your application. Sometime today, take a walk around your own home.
But don't look at it to count your water bottles.
No, don't inventory your pantry. Audit your connections. Count your pathways.
Yes.
If your primary path for climate control goes down tonight, do you physically know how to switch?
Ask yourself that.
If your primary path for communication vanishes, is your fallback pathway genuinely accessible, or is it just theoretically sitting in a box in the garage?
Look for the single points of failure in your daily routines.
And as we wrap up this deep dive, I want to leave you with one final thought to mull over. We put immense pressure on ourselves to build the ultimate self-sufficient household.
We do.
We obsess over our internal individual readiness. But if our homes are ultimately just routing nodes entirely dependent on the city's alternative paths, what happens when the city itself forgets how to switch gears? If the wider network has paved over all its own fallback pathways in the name of budget efficiency, how much of your family's resilience is actually completely out of your hands?